In this video, we will learn how to derive indirect utility function. The question is, suppose utility function is u, that is utility is a function of two goods x1 and x2, which is equal to x1 raised power 1 upon 4 times x2 raised power 3 upon 4, and we are also being given the budget constraint, that is p1 times x1 plus p2 times x2 is equal to m, where p1 and p2 are the price of good x1 and x2 and m is the income. We are supposed to find out the Marshallian demand function and indirect utility function. Okay, now to find out the Marshallian demand function, what we need to do, we want to maximize the given utility function, that is u is equal to x1 raised power 1 upon 4 times x2 raised power 3 upon 4, subject to the budget constraint p1 x1 plus p2 x2 should be equal to m. Okay, so when the demand of a good is a function of income and its price, we say it is a Marshallian demand function. Graphically, it simply means if we have x1, good x1 here, good x2 here. Okay, and we are being given the budget constraint. Okay, this is our budget line. Our endeavor is to maximize utility. Okay, so we want to reach to the highest possible indifference curve. Okay, with a given budget, we want to reach to the highest possible indifference curve. We want to achieve highest possible utility. Okay, so the point of tangency is actually our optimal bundle. Okay, now what will be our first order condition for optimization? Simply our, let me write it here, optimal or tangency condition or optimal condition for uh, maximization is here, that m or s should be equal to the ratio of the prices p1 upon p2. What is MRS? MRS is simply marginal utility of good 1 upon marginal utility of good 2. It should be equal to the ratio of the prices P1 upon P2. Okay. So the slope of budget line is actually the ratio of the prices P1 upon P2. Okay. And slope of indifference curve is actually our MRS. Okay. So tangency requires the slope of budget line. So this mu1 upon mu2 denotes the slope of the indifference curve. It is actually slope of indifference curve, and it should be equal to the ratio of the prices, that is slope of budget line. Okay, let me rub this out now. mu1, and let me write it here, mu1 means simply the partial derivative of utility function with respect to good x1, and mu2, marginal utility of good 2, is simply the partial derivative of utility function with respect to good x2. It should be equal to the ratio of the prices p1 upon p2. Now let us differentiate this utility function with respect to good x1. Okay, so by power function rule, the exponent of x1 will become coefficient, so we have 1 upon 4 x1, and exponent will be subtracted by 1. If we have x raised power n, its derivative is simply n x raised power n minus 1. In place of n, we have 1 upon 4, so we will have 1 upon 4 minus 1 here. Okay, so it will become minus 3 upon 4. Then we have x2 3 upon 4, because we are differentiating partially with respect to good x1, so x2 will remain same, divided by du upon dx2, this time differentiating with respect to good x2. Okay, so we have the exponent of x2 will become coefficient, so we have 3 upon 4, x1 will remain same 1 upon 4, and x2, its exponent will be subtracted, so 3 upon 4 minus 1 is minus 1 upon 4. It should be equal to the ratio of the prices. Okay, when you solve this simple thing, 1 upon 4, this 4 and 4 will get cancelled. We will be left with 1 upon 3. If I transpose x1 raised power, sorry, this x2 raised power 1 upon 4 to numerator, it will get multiplied with with this x2 raised power 3 upon 4. So 1 upon 4 plus 3 upon 4 will become 1. So we will get x2 in the numerator, and you can check it out. And similarly transpose this x1 here, we will get in denominator as x1. So we will have x2 divided by 3x1 is equal to p1 upon p2. Okay, you can check it out, which means x2 will be equal to 3x1 p1 if I multiply it divided by p2. Now what will we do? Simply we plug the value of x2 is equal to this back into the budget constraint. So in place of x2 I will write this stuff. So we have p1 x1 plus p2. In place of x2 I have this thing 3x1 p1 divided by p2 should be equal to m. Here p2 and p2 will get cancelled. We have 3x1 p1 and x1 p1, so it becomes 4x1 or 4 p1 x1, and it should be equal to m, or our x1 is equal to m upon 4 p1. Okay, so this is the Marshallian demand function for good x1, and it is a function of income and price. Similarly, to find the value of x2, that means the demand for good x2, simply plug this value into this function. So we have x2 will be equal to 3x, in place of x1 we have this stuff. Okay, m upon 4 p1, then we have p1 divided by p2. Here p1 and p1 will get cancelled. We will get 3m upon 4 p2. Okay, so x2, that is Marshallian demand function for good x2, is 3m upon 4 p2. Okay, so these are the Marshallian demand functions. Now to find out the indirect utility function, what will we do? And let me rub this out. To find out the indirect utility function, simply plug the Marshallian demand functions into direct utility function. So the indirect utility function is actually a function of income and prices. That is, let us denote V, that is utility is a function of price of good 1, price of good 2, and income. So this denotes the indirect utility function. Simply plug the value of x1 and x2 into direct utility function. So in place of x1 we have this m upon 4 p1 raised power 1 upon 4. In place of x2 we have 3m upon 4 p2 raised power 3 upon 4. This is our indirect utility function. Okay, utility function. Okay, I hope I make myself clear in this video. Thank you.